Welcome learners for the lecture 18 of a differential geometry. Today we given as some example about the direction as well as the angle of this form, because in the previous lecture sin theta and cos theta will be getting as a value in this both of this form of the equation. Okay, direction coefficient. Let us go find the parametric directions and the angle between of the points on the curve. For the parametric curves, v equals to constant and the parametric direction has the direction ratio du theta by v using its direction coefficient in this form. Okay, lm equals to du 0 square root of e du square, because all both of this term will be cancelling in this form, 1 0 square root of. In similar manner, the direction ratio of the curve v equals to constant r 0 and dv, so that its direction coefficient will be generated to the form l dash m dash equals to 0 0 dv g dv square 10 g. Okay, let theta be the angle between parametric curves, then by the theorem will be generated cos theta equals to f of square root of a eg and sin theta equals to h upon square root of a eg square. When theta equals to pi by 2, cos theta equals to 0, so that the condition of the orthogonality of the parametric curves f equals to 0. Okay, condition will be given theta equals to pi by 2 and cos theta. You know that cos theta will be considering to the 90 degree equals to always 0 in the orthogonality of the parametric curves f equals to 0. It should be noted to obtain the angle between parametric curves from the equation. Okay, r1 into r2 equals to mod of r1 into r2. This is the example will be given. Next example, for the cone with a vertex at the origin and a semi-vertical angle alpha, show that the tangent plane is the same at all the points of a generating line. Okay, we say or the explaining to the form. Okay, the position vector of any points on the cone with a semi-vertical angle alpha and the axis cone as a z will be considering. You know that r equals to u cos v, u sin v and u cot alpha will be given. Okay, now let us find to the fundamental coefficient. How to given as a fundamental coefficient? You know that fundamental coefficient is a r1 and r2, cos v, sin v and cot alpha, minus u sin v minus cos v and 0 will be considering in the r2. Okay, then e equals to r1 into r1 1 plus cot square alpha, they considering as a cos x alpha. You know that the basic rule or the basic formula will be given as a sine and cos form as well as a cot form. Okay, then function f equals to 0 will be considering, and g equals to r1 into r2, then u square sin square v plus cos square v equals to u square, and h square will be considering eg minus f square. They generating to the form that is a u square cos x square alpha, so that h equals to u cos x alpha. r1 into r2 equals to minus u cos v cot alpha minus u sin v cot alpha u will be considering, and n is the normal to the form, that is r1 into r2 upon h equals to minus cos v cos alpha minus sin v cos alpha and sin alpha will be given to the. Thus, the surface normal n is a independent of a u. This implies that the tangent of the plane is the same at all points will be generating of the line. Okay, this both of this independent value will be given. Then families of a curve. What is the explaining of the families of a curve? A single curve lying on a surface, only single curve is lying on a surface and associated tangential direction. Now we have introduced families of a curve on a surface and study of some basic properties of such families. Definition first will be given. Let theta equals to uv be the a single value function of a uv possessing continuous partial derivative phi 1 phi 2 which do not vanish together. Then the implicit equation phi uv equals to c, where c is the real parameters give the family of a curve on a surface, and r equals to r uv will be generated. Then different value of a c, we get a different curve of a family on the surface. Then we notice to the property through every point uv of the surface, then there passes one and only one member of a family. Okay, every point uv on the surface. Let phi equals to u0 v0 equals to c1, where u v0 is a point on this surface. Then phi uv equals to c1 is the member of a family will be passes to the form. Okay, hence through every point u0 v0 on the surface, there passes one and only one member of a family. Second, as noted in the form that will be generated, direction ratio of a tangent to the curve of a family uv is generated, already discussed in the above example. Okay, minus phi 2 phi 1 will be generated. Then go to the theorem first. The curve of a family phi uv equals to constant are the solution of a differential equation. Then phi 1 du plus phi 1 dv equals to 0. Then we generated in the conversely a first order differential equation of this form. Then p uv du plus phi will be generated, u equals to dv equals to 0. Okay, then p and q are a differentiable function. They do not vanish to the families of a curve. Then what is the proof? You know that to the equation phi 1 equals to del xi upon del u, phi 2 equals to del xi upon del v. We have to the from equation first, del xi upon del u du plus del xi upon del v dv equals to 0, giving to the del phi equals to 0. Okay, hence the conclusion that the phi uv c equals to constant to the value of a family of a curve with a solution. Okay, can you find to the value after that when put it to the equation? Yes, you find to the value because equation will be generated to the form. Then consider to the equation second. The equation is exact. It is not a general possible to find the single function phi uv such that phi 1 equals to p and phi 2 equals to q. However, we find to the value that is a lambda uv such that a lambda p is not equals to phi 1 and lambda q is not equals to phi 2. Then equation will be written in this form, that is a lambda du plus lambda q dv equals to 0. We have phi 1 du plus phi 2 dv equals to 0, so that the solution of a equation it is a phi of a uv equals to c. From above equation we get it as a form, that is the further from du upon dv equals to u by p, so that the direction ratio of a tangent to the family of the point p is a minus. Okay, this will be given to the significant value of the geometrical form.